Algebra 2 Notes, 7.4 Part 2, Properties of Logarithms. So as we learned yesterday, we have the product property, the quotient property, and the power property. We'll be using those to help us solve these logarithms. All right, write each expression as a single logarithm. Evaluate if possible. Logarithm base 4 of 2 plus logarithm base 4 of 8. Since we see this addition sign, that's going to tell me to use the product property. So we can rewrite this as logarithm base 4 of 2 times 8, which would be 16. And then we can use that, changing it back to exponential. Remember, a logarithm asks, what's the exponent? So if I put it back into exponential, it's going to say 4 to the x equals 16. Okay? So you can think of what 4 to what power is 16, or we can break the 16 down to be 4 to a power, and then just simply set those exponents equal. All right, second one, there's a typo, so use the 6 as the base. So since we're subtracting, we're going to use that quotient rule. So logarithm base 6 of 28 divided by 4. And then we can use, again, that changing it into exponential. So 6 to the x equals 7. And right now we don't have a way to do this. If I take 6 to the first, I get 6. 6 to the second is 36. So it's somewhere between 1 and 2. We'll find out later in the lesson how to evaluate that one. Okay? Evaluate if possible. This one we have not learned how to evaluate yet. All right, the third one, we're going to use the power rule. So remember, you can pop that 2 that was out front as the exponent. So that'll be 36, and then we can use the quotient rule and take 36 divided by 9. So now I have logarithm base 4 of 4, which we learned yesterday was just 1. Why is it 1? If I take the base to the power, I get 4. Well, 4 is just already to the first power, so your x is going to be 1. All right, again, we've got the quotient rule here, so 32 divided by 2. So we can rewrite it logarithm base 4 of 16. And we can say 4 to what power is 16? All right, sometimes we'll have variables in there. You won't be able to evaluate these, but we can still rewrite them as a single logarithm. So since we're adding, we want to multiply the product property. So 5 times 3 is 15, x times x, x squared. If we want to try to rewrite this, this one, I can't use x, I've already used x, so it'd be like 4 to the y equals 15x squared. So we have two variables, can't solve it just alone with that. All right, why don't you guys pause the video and go ahead and try the next 4. Okay, for the sixth one here, we can condense it to be logarithm base 2 of x to the 6th, y to the 5th. In the last row, we've got logarithm base 4 of 25. we cannot evaluate that one yet. We haven't learned a technique. All right, the next one, logarithm base 5 of, make sure you simplify this, 2/3. And the last one, logarithm base 10 of m to the third. As far as we can get. Okay, let's go ahead and expand these logarithms. So if we are dividing, we can rewrite that as two separated logarithms. So logarithm of 4x minus logarithm of y. Notice there was no base. That means it's a base 10. If you want to write it, you can. You don't need to. All right, this is one where you can pick what multiplies b20 or divides. 1 and 20, 4 and 5, 2 and 10. So if I picked 4 and 5, I would think of 20 as 4 times 5. So logarithm of 4 plus the logarithm of 5. All right, go ahead and pause the video. Try this third one. All right, it should be logarithm base 3 of 250 minus logarithm base 3 of 37. All right, logarithm base 9 of x to the 4th over 729. Again, you're just using that quotient rule. Now this one, since that 4 is there, we also want to bring that exponent to the front. 4 times the logarithm base 9 of x minus the logarithm of 729. Okay, another one similar to that, logarithm base 3 of 5 plus logarithm base 3 of x to the 4th, and then bring that 4 out front. Okay, and then finally, how do I write a square root as an exponent? We did this back in chapter 6. X to the 1/2. Remember, square root of x is x to the 1/2. So now I can bring that 1/2 out front. All right, finally, a way we can calculate these on our calculator besides being base 10. This is called the change of base formula. Okay? So if I want logarithm base 81 of 27, I could figure this out without a calculator, this one. I could go 81 to the x equals 27. Well, I can write both of these as 3 to some power. So this would be 3 to the 4th and 3 to the 3rd. So then we can set those exponents equal to get 3/4. Okay, there's another way to figure that out though. It's called the change of base formula. It says I can rewrite my logarithm base b of m as logarithm base c, which we're going to let the base c be 10 over logarithm base 10 because that's the one that your calculator can do over the b. So if I wanted to do this on my calculator, I could rewrite this logarithm of 27 divided by the logarithm of 81. This was on our sheet from yesterday as well, but we skipped it because I want to wait to cover it until today. Okay, so on your calculator, most of you can type it in just like that. Just make sure you in parentheses after the 27 before you start the second one. So if I go logarithm 27, my calculator, I have to type it in backwards, but if you have the blue calculators, you should be able to type it in just like this. So look in the in the history there, it says logarithm of 27. Then I want to go divided by logarithm of 81. So notice what the problem says, exactly what I wrote. And then you do need to push equals. Okay, and then it gives us that 0.75 number. Okay, go ahead and pause the video and try the last 3. All right, you can check your last 3 answers there and go ahead and get started on the assignment.